Hi, good evening, everyone, and welcome to the next episode or the next session of Azure AI Cohort. We have our expert speakers with us again, Ajay Kumar and Aditya Saladi. Let's welcome both of them. Hi, Aditya. Hi, Ajay. How are you guys?
We are good. How are you, Oscar?
All good.
Awesome.
No weekend for you,
No weekend for me.
like us.
Yes.
Yeah, cool.
So Azure works on every weekend. So he works more on
Okay.
weekends actually.
Okay. Does he get
Yes,
to take off on weekdays? I mean, the
that's more productive for me.
nice. Good to know.
So the stage is all yours. We can start.
Sure. Aditya, go ahead.
Okay, cool. Thanks, Oscar. Yeah. Okay. Hi everyone. I'm Aditya Saladi. Maybe I'll talk more about my introduction later. But before we get started, today's session, I'll just quickly give a recap on what happened yesterday. Right. So this is a 8 session series on Azure AI cohort, and yesterday was the day one, and today is day two. And yesterday we had a quick brief on what AI is in layman terms, and we also had a quick discussion about multiple topics on transparency, fairness, biasing, hallucination, and all this stuff between me and Ajay. And after that, we discussed a lot about types of AI and then the applications of AI. It's more on the basics of AI. So, but starting today, we are going hands-on. And if you have missed yesterday's session, there is already a recording in the Azure developer community. Please go and watch that when you get time. But again, even if you don't know anything on AI, this is a beginner-friendly cohort. So I personally recommend to go and watch day one after completing the day two. Right? Let's get started with today's session. So before I start, let me quickly introduce myself. I'm Aditya Saladi. I'm a software engineer at Microsoft. Been here from last more than 5 years, and started as an associate consultant in a global delivery team, and from there recently moved to the BCDR SRE team, and started my career in the year 2015. Worked in a couple of startups, and then moved to Germany. Did a program with BMW, and came back to India and joined Microsoft. That's my journey. And other than work, I'm a big foodie and I'm a traveler. So I've traveled more than like 10 countries. I'm planning to travel Bali in the month of April. So that would be my 12th country. And I usually post all that stuff in my Instagram handle. That's code with Adi, CODE dot with dot AADI. I also have a same YouTube channel with the same name, and I post Telugu tech content there. If you are interested in Telugu tech content, you can subscribe to my YouTube channel. Yeah, that's mostly about me, and I'll let Ajay to introduce himself.
Yeah. So
Take it
hey,
away.
hey everyone. I'm Ajay. I'm a principal software engineer with Microsoft right now. So I've been in the industry for more than 16 years now, almost 16 years. I started off with Wipro Technologies. I in 2009 I created a paper on cloud and grid. So funnily enough, after 15, 16 years, I'm still talking about cloud. And then now we have transitioned from cloud to AI. So it's exciting to be part of the community and then delivering these sessions. I worked with different companies. I worked with Goldman Sachs, JP Morgan in the past. I started contributing to the developer community in 2017. I created a tech channel called as Tech Primers. I never showed my face. It was just hands-on channel. After 2020, after COVID, I was part of the AWS Community Builder program for a couple of years, and then I joined Oracle Cloud. And right now I'm with Microsoft in the Azure space. So I'm right now in Chennai. That's where I am from. I have some superpowers. You can just take a look at it. Most of the time I just stay glued with computers, and I'm just keeping myself up to date with technology. Whatever I learn, I try to do some proof of concepts by coding, and then I try to share it with folks like Aditya and others who I meet along the journey, right? I have a YouTube channel called Tech Primers. If you're interested, you can just take a look at it as well, right? With that, I think we'll jump on to the today's session. Meanwhile, for people who did not join yesterday and who got delayed with the joining, so there are some resources which we have created in the GitHub for you to go and take a look at. The recordings are available in the github.com/tech handbook/Azure AI cohort. The links are there. The day one presentations are there. The assignments are also there. You can look at the submission links. Yesterday I mentioned about the submission links for the day one assignment. That is also there in that. And also we will be making the day two repo also available in few minutes. Also there are some discussions. If let's say you guys want to talk to us, if you guys want to like ask any questions or anything, you can just go to the discussions here. I will leave these links in the comment section. Aditya maybe will paste you these links in the comment section so that you can take a look at it, right? Also there will be everyday assignments. Like we mentioned, there will be goodies to share you guys. So take a look at these assignments and then just contribute, and also be a part of the AI journey along with us. There is also a bonus thing which me and Aditya are giving. So whoever is consistent throughout these sessions and assignments, the top two participants which we select will be getting 1 hour mentorship from each of us, right? So that's another bonus thing which we are giving to you folks. So with that, today's topic is all about fundamentals of machine learning. Yesterday we talked about AI and machine learning and multiple use cases around it. I also talked about Swiggy and Zomato, how they are using AI and ML in the customer service space. Today we are going to look at a little bit deeper on what is machine learning, what are the fundamentals of machine learning, right? You know about these applications, you use these applications, but then how do these function and what are the internals of these, right? So we will split this into three different parts. We'll just get into the definition of machine learning. What is it all about? We will talk about three different types of machine learning, which is there currently. And then also finally, we will see some hands-on on how we can use these machine learning types, right? And then do some coding with respect to Python and different libraries, which are already there in the internet, right? So that's what we will see today. There is also again an assignment on the hands-on part. If you like coding, if you like doing stuffs in Python or any language, just take glued for it, right? Now coming to the definition, I think by now most of you know what is machine learning. So machine learning is basically a subset of AI, which is artificial intelligence. Machine learning basically focuses on developing algorithms and statistical models which helps these computers to learn from these predictions based on the data whatever we provided it to those algorithms, right? So instead of being explicitly programmed for a specific tasks, like how we program something for a problem statement, instead what we do is we train these machine learning systems to improve the performance over a period of time by giving more and more data and exposing it to a broader set of data set, right? That's what machine learning is all about. And again, this is the reason this learning process allows machine learning systems to identify some patterns. It also makes some decisions based on these patterns, and then finally it adapts to these new data and the situations with minimal human intervention, right? So that's the whole idea of machine learning. Now ideally, if you just want me to put it in a single line, right, in essence, machine learning is about teaching machines to learn from an experience and also to improve from that accuracy and efficiency in performing some specific tasks, right? So that's what we are trying to do here. So we are making machines better and better by making them learn from the experience and improve the accuracy from the tasks which we give them, right? So that's what machine learning is all about. Coming to the types of machine learning, there are three different types of machine learning: supervised machine learning, unsupervised machine learning, and reinforcement machine learning. These are like high level categories, and most of these LLMs and then programs whatever we try write using these machine learning algorithms and libraries, they fall into this category. I'll also explain about all these and then give them examples. But at a high level, if you want me to summarize in a single sentence, supervised learning is something like training a model on a labeled data set. That's what supervised learning is all about. Same way, unsupervised learning is something where I don't know the data set labeling. I don't know what type of data is this. I don't know the classification. I don't know what type of data is I'm feeding it to the algorithm. So that is called as unsupervised learning. And finally, for reinforcement learning, we want to create agent-based learning where there is no human involved. I want the system to self learn and also perform actions based on these particular learnings. And that's what reinforcement learning is. Again, ask any questions in the comment section, in the chat section. Aditya would be able to respond. If not, I will also respond as well. So do ask the questions as well. So coming to the supervised learning, like I said, it involves training a model on a labeled data set. The labeled data set is something like you have identification of this data classified as a particular example, right? I mean, for example, let me show you an example of what supervised learning is, right? Let's say there is a spam detection tool, right? we know that we need to classify these based on some predefined rules or algorithms, right? So that is where we know what is the labeling, and that is where we know what is the type of data set we are feeding to these systems. Same way, a regression prevention system where we want to predict some flow of prices or maybe stock prices. In this case, I'm just showing an example of a house price, right? What will be my house price in the next few months in this particular area in Hyderabad, right? Let's say. So that is an example of how you can get supervised learning and then predict prices for the house in that particular area, right? Based on the data set what you can provide, right? So that's where supervised learning comes into picture. The general process is something like this, right? The model is basically trained with an input output pair. So for example, if I give this input, this is the output, and then the algorithm learns and then tries to map these outputs with the inputs, right? And that's how the system learns, right? So that's the entire process of supervised learning. The goal of our supervised learning is to minimize the error between the predicted output and also the actual output, right? So that's the whole goal of supervised learning. So we are not trying to say that we need to be 100% accurate, but then we want to improvise and then make minimal errors, because if you make it 100%, then there is no guarantee, right? I mean, you want to predict something and there is no guarantee that it will be 100% right. So but then we want to minimize these errors and we want to keep on training these algorithms again and again, right? So that's why I'm saying that we want to minimize errors, right? And that's where supervised learning comes into picture. Now coming to the LLMs, which are designed and which can support it, BERT from Google is a pre-trained large language model. Again, it can be fine-tuned for some specific supervised tasks, something like sentimental analysis or maybe like question answer kind of a thing, or you want to do a named entity recognition, right? So that is again possible with BERT. Even GPT-3 can do a lot of these capabilities. It is also again fine-tuned to do some text classification, translation, summarization. I sometimes use Copilot with GPT-4 a lot, right? It can do summarization. If let's say I have to like summarize some of my mails and things like that, I use it day in day out. Again, T5 is another LLM where you can do text to text transfer. Basically, it does the same thing using natural language processing. It can convert and summarize stuff into a smaller and a more meaningful data, right? So this is where supervised learning comes into picture, and these are the LLMs which we can leverage for supervised learning. Now, how can I correlate to an example? Like I said, there is a, let's assume that there is a case study on, I want to build a system for detecting spams in my inbox, right? So we have an email spam detection system. We get a lot of these data. The crux of this is we do classification based on the email sender, content, and also the type of messages they are sending, right? This is how the classification is done, and these are all done based on existing patterns, right? So the algorithm doesn't necessarily mean that it has to identify who the senders are, who, what type of content it needs to be getting, but it also understands and learns from the pattern in which these spams are created, and then it can classify new information which is not even in the history or the data set which it was trained on, right? That is how the spam detection algorithm works, and that's a classic example of a supervised learning methodology of machine learning, right? Now moving on to the unsupervised learning. With respect to unsupervised learning, it again deals with unlabeled data. If let's say I have huge number of data set, right, and I want to train my algorithm, the model tries to learn the underlying structure first, right? Also, it can also look at the distribution, how the data is distributed. Like, is it like having any geographical information, or is there any meaningful data which I can share across my data sets, right? That's what unsupervised learning algorithms do, right? The examples of this is clustering and association. For example, like I said, you want to create a customer segmentation, right? With respect to buying patterns, I want to create different clusters of customers. I can do that. I also want to do a market analysis, or I want to create baskets of different categories, and then I want to associate them together, right? That is also possible with the unsupervised learning, because the data again is unstructured, right? I want to make it structurized, right? The whole process again is to identify patterns and relationships in the data, and that's what unsupervised learning does. Using these relationships, we narrow down to a specific category of association or clustering, and create algorithm and analysis based on that, and then again predictions are also done based on it. The goal of unsupervised learning is specific to discovering hidden structures or patterns from the data, right? So the goal is not to like identify a solution out of the data set, but then to identify hidden structures and patterns, so that the machine learning algorithm can use these patterns to predict some things which we did in the supervised learning, right? So it enhances the existing supervised learning and makes the data set training model better and better, right? Comparing to the LLMs, so again, BERT has a way to do unsupervised tasks, right? It can also act like a masked language model, right, where the whole model predicts missing words in a sentence, right? So that is also possible with BERT and these kind of LLMs. GPT-3 can also do the same kind of stuff. It can also help in predicting and also modeling and clustering data, whatever you give. The most common one which you would have heard is word to vector. Word to vector is a very old algorithm, right, which is used to, it's not a large language model per se, but then it's a classic example of how a supervised learning model can learn from word embeddings, right? From a large text, it can understand and capture semantic relationship between words, and that's what we want with respect to supervised learning, right? We want to understand relationships and patterns, and word to vector helps in that. To some extent, GPT-2 version also was doing that, right? So these are different examples of LLMs using unsupervised learning. Now, coming to the example, I will be just picking up a customer segmentation. Let's imagine that there is a big billion day and Flipkart is doing data analysis on their um, customer spends, right? There are two different categories of customers the algorithm can create, right? High spenders and low spenders. Now, since we have two different categories, how can I use these data and then maybe increase my customer penetration, or I want to sell a specific category and I want to cater my audience towards that, right, or the customers towards that. So I can maybe, let's say I'm launching a product which is above 1 lakh or something. I know that the high spenders are able to afford to that particular product, so I can use my marketing team to go and run campaigns with the high spenders, right? Same way for the low spenders, I might be launching some Xiaomi phones and the low end phones which will be catering towards the low spenders, and I will concentrate on those customers rather than concentrating the entire set where I may not result 100% yield, right? This is how customer segmentation is possible with unsupervised learning. And classic example is, like I said, Flipkart or Amazon or any e-commerce and quick commerce companies will be using these or can be using these to market and then create better customer segmentation so that they can have more marketing strategies run with them, right? So that's where unsupervised learning comes into picture. Coming to the reinforcement learning, so reinforcement learning is again the last type of machine learning where an agent interacts with an environment. Imagine it like a daemon process running, and then it can interact with the environment. It also learns from the output. It learns from the emitted data, emitted information, and also it can perform some specific actions to maximize the rewards or basically the outcome, right? So that's what in essentially is reinforcement learning is. A classic example would be playing a game. We talked about AlphaGo, where you can play a game, right? An AI agent can go and play games with like maybe humans or maybe robots, right? The other example is robotics. We talked about how we want to evolve into a robotic kind of an environment, and that's where reinforcement learning comes into picture. So we want to create a robot which can understand and learn from the environment and then perform specific actions to maximize the cumulative rewards, right? So that's what reinforcement learning is. The process involves again creating and receiving feedback in the form of rewards or penalties. So penalties are basically, let's say you have a wrong information or something didn't go right, right? So you take care of it as a penalty, and then you try to make the algorithm better and better, right? So that you can adjust these actions and then again maximize these rewards. That's why we're talking about rewards and penalties, because it's something like you get a reward if your agent is behaving well and then the outcome is well received. If not, it will be a penalty, and then it just makes it better and better, right? That's how reinforcement learning is, and that's the reason why it's called reinforcement. Your algorithm learns from these actions and the outcomes based on the rewards which it gets, right? So again, the goal is to learn a policy that maps and states an environment to an action to maximize the long-term reward, right? I think you will be clear once I explain that in the next slide with an example, right? uh, Coming to the LLM part, there are existing deep QN DQN networks like the deep Q learning neural networks, right? It has been used successfully in various applications, including the playing games. For example, there are Atari games, which can play at a superhuman level, right? DQN has helped there, right? Same way the proximity policy optimization is another policy gradient methodology which balances and explores an exploitation, right? So that is one. And again, we talked about AlphaGo and AlphaZero. So these are different LLMs and different bots or agents which have been created to do reinforcement learning. The last one is again A3C, asynchronous advantage actor critic. This is a model which uses the concept of multiple agents, right, to explore an environment in parallel. So instead of just having one agent to explore an environment, it uses multiple agents and then it explores the environment in parallel, and it also helps in stabilizing and then speeding up the learning process, right? So those are different examples of LLMs which are there. Now, coming to the example, like a case study, I would say autonomous driving is an example of a reinforcement learning methodology. These days, everybody is launching EV cars. In fact, last week I saw, or this week I saw Mahindra launching their own new EV sector. There are two different cars which have been launched, and I was pretty much impressed with the auto parking stuff which it did, right, without anybody sitting in the machine, and then it automatically does it. Now, how does it do it? It has an agent which can understand different data. For example, this is how when I went and found out how it can be done, there are different levels of sensors, different levels of adaptations. For example, if you see, there is adaptive cruise control, there is emergency braking which needs to be done at different level, there is traffic signal recognition which needs to be done at some level, right? There is also parking assist, then there is surrounding view, blind spot detection, and also finally the surround system view, and then real collision warning, right? So all these are different methodologies, and then the agents or the processes or the daemons which are running inside these machines or the cars needs to react to these inputs and react to these data and then take action based on that, right? So that's an example of a super reinforced learning, right? How you can use algorithms within these environments and then learn from these current environment and then take actions based on that, right? So that is an example of reinforcement learning. Now, what is the goal of all these three, right? Just to summarize and finish off the theoretical part, right? Supervised learning helps us in minimizing the error between the predicted output and the actual output. Unsupervised learning discovers these hidden structures or the patterns in the data, and reinforcement learning creates a policy and also it learns from that and then maps to the current environment and takes actions and maximizes the long-term rewards, right? So all these that's what all these learnings are all about, right? These are three different types of machine learnings. When you are creating machine learning algorithms and when you are using these machine learning LLMs or models, make sure that you understand what type of data you wanted, what type of data categorization your data falls into or your query falls into, and then take action based on that, right? With that, what we will do a hands-on activity, right? I'll let Aditya take the stage for the hands-on. I'll ping this GitHub link as well in the comment section, so if you guys want to walk through the steps, you can do it as well together with Aditya, but Aditya will show you guys there, right there. So Aditya, if you can share your screen, we can.
Sure, sure. Yeah. Let me just quickly share my screen.
Yeah.
Let me know once you can see.
Not yet.
Okay. Now,
Still no.
still no. I'm getting an option to stop sharing. Let me just stop
Oh,
the sharing and share it again.
okay, sure.
Yeah. Yeah. Share screen. Share screen.
Or maybe we need to promote to stage, I guess, right? The promotion. Maybe that's why I don't see it.
No,
Or
no, I think we can see it now.
yeah, yeah. I think it's possible now.
It's
Yep.
visible, right?
I think we are
Okay,
good.
cool.
I can see your
Uh,
Jupyter notebook. Yes.
Jupyter Notebook, right? Okay,
Yeah.
perfect. So, do we have an option to like allow the participants to vote? Um, Azure, I
Voting,
just
huh?
want to check. I just want to see if participants are well aware of Python before I get started.
Mm. No,
So
I guess.
I'm
I think what you can do, yeah, maybe people, if you guys are well versed in Python, I mean, just show a thumbs up or say yes or something maybe in the chat, so that
Yeah,
way
yeah,
we
yeah.
can get to
So
know.
if you know
Yeah,
Python, at least the basics of Python, how to make a
yeah,
for loop, how to make a print statement, just say an S. If you are not well versed with Python, just say a no, so that I'll understand the kind of participants we have for today's session, and based on that, I can uh, like explain the details. Okay, Suman is saying yes. And Suman,
awesome.
I think I actually tried to reply to your message there. You asked whether we should submit the assignments before the start of next session. Maybe what we can do is, um like, we'll Ajay, maybe we can have the
Hmm.
winners announced on the like Friday
Next week,
or
right? Yeah, yeah,
next week,
correct. Yeah, we
next
can do
Friday
that.
for
Yeah, yeah.
day one and day two, like for the
Hmm.
previous week, right?
Yeah,
So maybe we'll keep the window open for like Friday and Saturday sessions till the next Friday, right? And we'll announce the winners maybe on Friday, right? So maybe the windows you can consider Thursday as the last day for submission.
sure.
Okay, I see two no's and one yes, maybe, but for now I'll like begin with introduction of Python, so that maybe I'll just quickly tell you how Python works. What is this Python programming language? What is it used for? Otherwise, it will be like it won't solve the purpose, right? So you need to understand this code base. So for that, you need to know at least the basics of Python. So to give a high level, Python is a high level general purpose programming language designed for readability and simplicity. If you see any code base in Python, maybe just go to GitHub and search for random Python code base. If you just go through that, you feel like reading a poem, right? So you don't even have to, it doesn't have any brackets, brackets or square brackets or anything much of that. It will be like line to line, mostly written in English, right? So the names, the function names, even the class name will be saying definition and then the class name. So if you read it, you'll understand, and it actually is very easy to relate, right? So but when you look at any other programming language, it's not the case. So you may find a little difficulty in reading through the uh, uh, like the programming language and understanding it, right? And this supports multiple programming patterns. Like there are multiple patterns like oops, object oriented programming, or procedural programming, or functional programming. It supports all the programming types, right? And if you go a little into the history of this Python, this is invented by Van Rossum in the year 1991, and he actually inspired from the programming languages C and ABC. ABC was also another programming language back then, and few other programming languages. And then he understood the flaws of each of these programming languages, and then invented this Python. And current stable version is Python 3.x, which is currently I'm using 3.12. It's a stable version for Python. And where do we use Python? Python is used in different areas, starting from web development. In web development, we have a framework called Django and Flask. So with Django and Flask, you can do the web development, and it's used in data science and machine learning, which we'll be seeing in next few minutes, right? So we have multiple libraries like NumPy, Pandas, Scikit-learn, which is the library that we are going to use for today's demo, and also TensorFlow, right? So all of these libraries are supported in Python, and it's used in all this NLP, computer vision, and robotics. And one of the major use cases, it's mostly used for scripting and automation. So when there is a repetitive task, all that scripts are usually written in Python. And there is also a framework called as Pygame, where you can develop games as well, and that's also quite famous. And this is also used by a lot of scientists. So recently, when I was flying to Punjab, I met a scientist who works on biology, right? And he's trying to make some medicines for some disease on lungs. And he is very much equipped with everything that's required for Python, right? And when I asked why he learned Python, he because he needs that for developing all his scientific computing and all that stuff, right? So it has a lot of libraries which support scientific computing. And then education. So if you are learning programming language, most of them usually suggest to start with either C programming or Python programming, because both of them are easy to start with. And also, even in competitive programming, there are a lot of people who ask me, how do you do competitive programming? Most of the beginners start with Python, and it's easy to solve problems there with Python, because you don't have to write much of the code there. And while on Python, I think, as already mentioned, it's good with readability. Other than that, there is a lot of community support, and libraries and framework. It supports cross-platform Windows, Mac OS, and Linux. And other than that, all of these areas, whatever we've discussed, scientific computing or AI, ML, have a lot of good job opportunities. So everyone prefers to learn Python language as a first step in the programming journey, right? And then how does Python works, in sense like how is it compiled and executed? So Python is executed line by line, and using a Python interpreter. And Python internally compiles the code into a intermediate code base, which is called pyc files. It's with the extension .pyc. And once it is executed, it will be executed using a VM, Python VM. It's called pvm. And the pvm will execute the .pyc files, which is nothing but the bytecode, right? And maybe I think good. I hope now you at least understand what Python is, why it was invented, and why we should start using Python. Right now, I'll quickly show you how we can write a simple program in Python. So one thing, you can either directly install Python from I think python.org is the website, I guess, if I'm not wrong. But just go to Bing and search for Python, and you'll find a first link where you can go and download and install it. Or else, my personal preference would be to go and work with Anaconda. So when you install Anaconda, Python comes by default. So just go and install Anaconda. It hardly takes like maybe 20-30 minutes max. But once you install Anaconda, this, I hope you can see this screen. So this is the home screen that you get. There are multiple tools in this. So in that, you first go to the notebooks. Uh, this is this is Jupyter Notebooks. You just launch it. Once you launch it, it will automatically open a page like this on a local host. So this will be the page, and here you can choose the Python files. But in our case, I wanted to quickly go and create a new file. So I'll click on new and Python 3 here. It will open a new tab. And here, I'm not sure if you know any other programming language. If you are well versed with any C sharp .NET, there if you want to print something, we'll say console.writeline and hello world. Or if it is in C programming, I think we'll say print C, right? In a similar way, in Python, it's very simple. For printing anything, you'll just say print, and just open the brackets and say hello team. Why to say hello world every time? So hello team. So it will print you that. So the reason why I'm using Jupyter, so you can break your program into small chunks and test it there and then, instead of writing a whole like big piece of program and going and executing it. Instead of that, we can just play with small lines and see what is the response of that line, right? And other basic concepts are, I think after printing we'll usually learn about variables. Variables are very simple. You don't have this complex data types like float, int, string, and all that stuff. It's all dynamic. So you just say name equal to Aditya, right? And then the value is assigned to name. Now you say print name and click on run here. This will be printed. And now say this, maybe you may be thinking that just because it's a string it's taking. Not really. If you just add one more line and say maybe age equal to 25. So here we are not writing any data type. We are just giving a variable name and assigning a variable to it. Ideally this is a number type, right? So it will understand we are assigning a number type to it, so it will understand that age is of number type, right? So if you run this, it is assigned. Now if you say print age, it will just print 25, right? In a same thing for boolean variables as well. In for booleans, what you do is you say is true equal to true, it will automatically be considered as a boolean variable, right? And then how about the if clauses? I mean, like conditions basically. You'll say if I'll say age is we said age is 25, right? So like I'll say if age greater than 18. So uh, for us to end the condition, we need to add a, semicolon and then say, oh no, how to go to the next line? Yeah, if age greater than 18, I'll say print adult, right? And we don't have to end this with semicolon or anything. You can just go next. And and all of this works on indentation. So whenever you are done with your condition, now if you want to write a else block, you just go to the same level as a if and come here, go here and say print if that is the case, um, print. Okay, I'll just see if this works. Right. See, in our case, the age is 25, so it's printing you're an adult, right? This is how conditions work. The same way, if you want to write a for loop or a while loop, this is how you write. You just replace that with for. Maybe I'll just show you for loop because in any other programming language, like maybe C, you might see this syntax where for at least in C sharp, we write int I equal to 0, I less than 10, and then I plus plus, right? If it's in C programming, I think this dynamic initialization of variables won't work. I don't remember, but yeah, this is how a usual for loop looks like. And then you have a flower braces and add the logic inside that and all that stuff. But in Python, it's made very simple. So we'll say for I in range of 5, we'll just say print I, okay, and let's run this program. So see, we are just saying I in the range of 5, and as you know, the numbers in programming always starts with 0. So for the first 5 numbers, we are repeating on for the first 5 numbers. If you want to write the same program in C, you will say for I equal to 0, I less than 5, I plus plus. Same thing can be written in Python this way, in a simple way, right? 5 in the range of 5, and we are printing the value of I inside that for loop, right? So this is how we write a simple for loop, and I'll end with how we write a simple function, right? So that's the last one. So so I'll say if you want to write a function, you just say df, and I'll say greet, and I'll maybe pass the name here, right? And inside this, I'll say return hello and name. See this? Let's run this. Right now the definition is done. Let's add a block and say greet Aditya, right? And see what is the output of this. See now it's saying hello Aditya. Whatever value we pass to this, that will just create it with that name. So this is how we write a simple function in a Python programming language. I'm just giving you examples, basically how we write the syntax for each of these basic concepts for a function or a loop or variable or whatever, right? So these are the basics of Python programming language. Hope you now understand the basics of Python. For those who said no, I just want to hear it from you. Uh, I'll watch the comments for a few seconds, maybe.
I think we should spin off a Python programming session also.
Yeah, I think maybe 50% of the basics are done here.
Yeah, yeah. That's it.
Okay, that's awesome. I think who said no? Karthik said no. Mukesh said no. Okay, awesome. We get S from both Karthik and Mukesh now. Perfect. So,
Awesome.
perfect. So now that we understand the basics of Python, now let me go to the main concept of what is this new term that we are talking, right? That's AI using Python, right? Why should we only write uh, any AI modules or any AI models using Python? The first reason is, I think, as we discussed now, there are a lot of libraries which are built on Python first. And I see someone is a Java fan. Yeah, we have libraries in Java as well and .NET as well. But when you compare the number of libraries that we have in Java versus Python versus .NET, we have more in Python, and the community support for Python is also so much, right? That's the reason we always prefer to use Python when we are writing any models, right? And then what is this library called sklearn, skikit-learn? SCIKIT dash learn is a library that we are going to use for today's session. So that's again a library in Python where we have predefined data sets, right? Again, before even I go into what a data set is, what a algorithm is, I think in Ajay's presentation, we might have learned two concepts. One is supervised learning and unsupervised learning, right? Example, take an example of supervised learning. Maybe let's say if we have a data of uh, maybe people having a lung disease or a lung cancer, right? If we have the data of the parameters that are flagged as red, uh, uh, like before the stage of the cancer, right? And if we have the data for like last 1 year or 2 years, and if we can have a algorithm which can understand based on the data, and now whenever we pass a new report to this algorithm, that should be able to predict whether this guy is having a cancer or not, right? So that's how supervised learning works. So any data that has proper labels and properly structured, and if that can be trained properly on an algorithm, so whenever we send a new parameters in a similar format, it should be able to identify whether this guy has a cancer or not. I'm just telling cancer as one of the examples. Maybe what you can do is, maybe if you have the data of flowers, right? Maybe rose flowers petals are maybe 5 centimeters. Rose flowers color is red color, right? So now for rose flower, we'll have two parameters, two labels. One is the color and the size of the petals. Even in the size, we have two parameters, length and width, right? So now I'll say rose, red, length is like 5 centimeters, width is like maybe 2 centimeters, right? And then lotus, color is so and so, length is this many centimeters, width is this many centimeters. In a similar way, if I can form a library of all the flowers, maybe millions of flowers that we have, right? And then now after training the algorithm on this data, and if I come back and send a new parameter saying I see a flower which is of color black, and its petals are like 5 centimeters in length and 2 centimeters in width, it should be able to identify the pattern and give me the kind of flower like based on these parameters that we are passing, right? That's how supervised learning works. When it comes to unsupervised learning, so say you have a, what can we say for unsupervised learning? We have a random data, right? And we need to classify this data into different groups, right? So Ajay, did we already discuss some example on
Yeah,
unsupervised
yeah.
learning?
Flipkart. Yeah, yeah, yeah.
Flipkart,
Flipkart.
yeah, Flipkart, right,
High
right.
spenders versus low spenders. Yes.
Perfect, perfect. Yeah. So if you pass the data of that profile, like say in terms of Flipkart, Swiggy, or any other e-commerce website, right? If you pass the kind of expenditure they are doing, if you see the orders history, you should be able to classify that user whether he's a low spending user or a high spending user, right? So that's one example of unsupervised learning. So are we going to build a algorithm for this supervised learning or unsupervised learning? No, not in this session. What we are going to do is, using this scikit-learn library, we have a, library algorithms already defined there, and we also have data sets there. So we are going to just use the data set and the algorithm that's already defined, and see how to work around with that. Like say, let's take the example of this flowers only that I was talking. Let's take that data set and put it on a supervised learning algorithm, and let's take another data set, maybe 10%. Like say if we have 100 records, let's take 80% of the data for training the model, and let's take the remaining 20% of the data just for testing the accuracy of the model, right? So maybe if you take 80% of the data for training and 20% of the data for testing purpose, what will happen is that 20% will be sufficient for us to understand the efficiency of the model, right? So what we'll do now, first thing is, we'll find the data, right? And then using that data, we'll also fix one algorithm, and use that algorithm for training this data. And even that data, before we start using that data, we'll classify some part of it as training data and some part of it as testing data, right? And we use the training data on top of the algorithm, train the algorithm. And once the algorithm is trained, model is trained, what we'll do is we'll send this testing data and see the accuracy of the results. Ideally, because in the testing data we already know the results, because in the testing data for the rows we already have the parameters, and if we pass the same parameters, we should get the rows as a result, right? So now that we know the results of the 20% data, we'll test the accuracy of the model. And if the accuracy is close to 96 or 97%, I think we are good to go with that data set, right? So let's get started on that. Do you have any questions on what we are going to do now? If yes, please raise your questions in the chat. If not, we'll just continue. I'm creating a new fresh book. So this will just leave it for Python basics. So first thing that we need to learn is we need to install this library, which is nothing but the skikit learn library. So let's for installing that, the command is uh, pip install ski ci. I'm very bad with spellings. Git learn, and for running that, you just have to click on this run this cell. So whenever you see a star mark, which means the command is processing. So once we see either 1, 2, or some decimal number, you can understand that this specific command is processed. So let's wait until this command is processed, right? So it's saying now you may have to restart the kernel and all, but that's okay. Let's go ahead and import the libraries. So in the scikit-learn, we'll have multiple different libraries. So we are using iris dataset, which is from the scikit-learn dataset, and the short form for that is uh, from sklearn dot datasets import uh, load iris. Let's see if this statement is correct or not. Let me just click on this. Yeah, this is executed properly, which is correct, right? So then I already have this code open with me for importing. I'll just quickly show you how we can import. So these are the 3 lines that we need to add next. Then from the model selection, we'll say we are using random forest classifier, where it will classify the data, and based on that, if we pass the test data, it will be able to identify which category it belongs to. And let's import all these 3. model assemble and metrics. So it is imported. So let's get this iris. Where did we import iris? Yeah, iris data into a variable. So for assigning a variable, what we need to do is, sorry, what we need to do is just give the name of it. I'll just name it as iris, and I'll say load iris. Right. Let's have it in this variable. Okay, now the iris is loaded. So let's see if it is loaded properly. For testing purpose, let me just print this. I'll say print feature names. Iris, iris feature names. Let's see. Right. So as mentioned, uh, we have sepal length in centimeters, sepal width in centimeters, petal length in centimeters, and petal width in centimeters. These are the what we say rows columns we have, right? Column. These are the 4 column names that we have, and this is under the feature names. And then let's also test the data, the target names, right? Start. So these are the 3 target names that we have, right? So it's hard to pronounce, but yeah, these are the 3 target names that we have in the data set. And then let's
I think we should
split
learn
the data.
biology. We should have
Yeah,
become doctors to learn this data.
right.
Mm.
So I'm actually scared to pronounce this because I'm sure I'll be pronouncing them wrong.
Yeah,
So
yeah. People have been already highlighting.
yeah.
Yeah, no worries.
Yeah. So this is the data that we have, and then we'll split this data. So once we, because that now we have the data in this iris variable, we'll just split this, some part of it as training data and some part of it as testing data. So I'll just give the test size. So right now I'm taking, as mentioned in the example, we can take either 20% or 30% of the data for testing purpose. So in my case, I'm taking 30% of the data. So that is like we have xtrain, xtest, ytrain, and ytest, and train test split is the method that we've imported already. Again, this is a predefined method. I'm not creating it myself. This is from the library, and here we are passing the iris.data and the targets that we just printed, and the test size we are saying test size we are saying is 0.3, which is like kind of 30% approximately. And then the random state is 42. The reason why we had this random state is, as you know, this AI algorithms will give different results. Maybe the positive or the negative response would stay the same all the time, but when we select the kind of randomization, if you put 43 in the next time when you're running it, the responses would be little different, right? If you want a same response, it's better way, the best way is to have a same random state. So that's why we use this variable called random state. And then let's see if we can split this data into 2 pieces. So yeah, now that is done. So now let's create a model. So as we mentioned, we are going to use the model as a random forest classifier. So I'll discuss about the different other different options we have other than random forest classifier. So I'll just say model equal to random forest classifier. And even for this, one thing that we commonly give for whenever we are like splitting the data or doing this classification, the random state variable, so that we get the same results every time when we test on this data set. Equal to 42. Right, let's load this as well. So now we have everything in the model. So now for us to test the model, now we have the model in this variable. So now what we need to do is we need to fit this data into this model. So for that, what we have is we have a method called fit. So we'll just say model dot fit x test, which is this. Sorry, this is not testing. This is for training. X train and Y train. Right, so we'll just have this now that now our model is ready. So the data is properly loaded into the model, in sense like the model is trained on this data. So we also have the output saying that the random forest classifier is now ready with randomization state as 42. So let's go to the next step, and let's do the predictions using the test data that we have. So using, I'll say,
So just to summarize, as a part of the seventh command, right, train underscore test split, we split the data into the test data set and also training data set, right? And then we are just getting the training data set, putting it in the model, and then training it. Now we are using the test data set, right? That's what we are doing.
correct,
Right.
correct,
Okay.
correct. So now that we have trained it, now we are going to predict the accuracy using the test data set. For that, we'll use the X test. So I'll just quickly run this. So let's now print the prediction. So what we'll do is print, let's see, predictions. We have some predictions. Now let's check on the accuracy score. Uh, so for getting the accuracy score, we have so that now we have predicted the numbers classification on this X test. So what we can do is we have a method called that we imported called accuracy score. We can test the accuracy score using this accuracy score method. So so that will load it in the accuracy variable. Just copy this.
So we compare that accuracy with the test data set what we got earlier,
Correct,
right?
correct,
Yeah.
correct.
So whatever we got predicted, we are testing with the test. Okay.
Right. So now let's do the accuracy. Like let's print the accuracy now. So we'll say print. Have the accuracy. See, we'll do the percentage of this 100. Let's see what is there in accuracy first. It should be 1 or 0.1. Let me just this. Yeah, 1.0. It's like I think it's
Hmm.
100%, but let's have it in the percentile format. For that, we have a formula to do that. Let me just get it here. So how this will properly get the model accuracy is 100%, but this won't happen on a in usual cases, because that just that we are testing it on the random data sets, in sense like properly collected data set, we are getting this accuracy. But in a usual scenario, what we get is close to approximately 85 to 95 percentage of accuracy is what we usually get. And for production, what they choose is they choose any model which is having more than 96% of accuracy. That's what usually happens, right? So this is how we have tested this specific data related to the petals, the flowers, basically using the iris data set. And we've used this algorithm called random forest classifier. So any questions so far before I jump into the next stuff?
I don't see any new questions though.
Okay. So just that we have used this random forest regression classifier. In a similar way, we have different algorithms called logistic regression, or SVC, which is like support vector classifier. Uh, these are all supervised learning algorithms. And there is one called KNN, K-neighbors classifier, and decision tree classifier, which builds a tree structure for classification decisions. And we have another called as gradient boosting classifier. This is another kind of technique for building the same trees, just like the decision tree classifier. You can find all these details in this skikit uh, learn library. This documentation is really good. I was just going through this documentation for seeing the for this random forest classifier algorithm. Let me just open that. So if you see this, for classification, for regression, for clustering, for dimensionality reduction, for model selection, pre-processing, we have algorithms for every purpose, right? And just go through this documentation. It's really interesting. And even when you are writing your assignment for this session too, the assignment will be really interesting. We'll open that in next few minutes. So for that, we want you to test that in all these different algorithms, and share the results with us on the GitHub repository. We'll come there in few minutes. uh, and then when you think about unsupervised learning, right? For unsupervised learning also, we have different algorithms like k-means. K-means is like clustering the data into k different groups, and that k can be configured by us, right? And then we have something called as db scan, which is like groups data points based on the density. That's another algorithm. So one use case for dbscan is for detecting anomalies in data sets. We usually use dbscan. And there is one algorithm called pca, which stands for principal component analysis, which is used for it actually reduces the dimensionality while retaining the important information. And one use case for pca is visualizing high dimensional data sets. I think this is mostly used for high complex computing. And there is one other algorithm called isomap. We also call it as tsne. Again, this is also used for dimensionality detection for nonlinear data sets, right? Let me just quickly show you an example on how we can do some clustering using k-means, which is unsupervised learning algorithm, right? Let me go back to our Jupyter notebook. And let me maybe use a different window for this. So I have all the load commands already. So here I maybe this will be little interesting. At least you'll see the plotting of the data sets, so you'll understand how the grouping actually works. So here we are again using the same data set from Iris, load Iris, and one difference here is we are going to use k-means algorithm. And for plotting, we are going to use a matplot library. So that's a new library. that we are going to use in this example, right? So this is done, import is done. So as mentioned, so one is load iris. You already know this. K means we are going to try this algorithm now, and we are using this for plotting purposes, right? And then will second step. What should be the second step? I just want someone to answer this. Now that we have loaded all the libraries, what is the next step? Ajay, just monitor if there are any responses coming in.
Yeah, yeah, yeah. I'm just checking. I cannot leak answers, so
So for the code, Satvik, will share all this code in our GitHub Day2 repository. You can find it there. Okay, import iris, perfect. Okay, so we need to get iris loading the data set. Cool. Yes, we need to do that. Um, so so for that, the command is simple. Iris equal to load iris. Right. Let's execute this, and let's also get the data in a variable called data. Data equal to iris dot data. Right now we have the data in this. So now let's initialize the k-means. I'll say k-means equal to, let me get this k-means, exact same method that we imported, right? And let's let's categorize that for timing. Let's make k as 3 for now, right? I'll say n clusters equal to 3, and for randomization let's use the 42. That's a usually we use the randomization number as 42. I don't know the core reason for that, but yeah, we can use any other number as well, right? So k-means, we have k-means now, and what is the next step? Now that we have data, we also have the algorithm in hand. What should be the next step? In this case, yeah, so in this case we don't have anything to test as such, right? We are just plotting the data and seeing. So do you really need the testing set here, in sense like, do you think we need to split the data for testing and training? I just want yes or no.
I think Satvik is saying plot.
Plot, okay. No, not plotting yet. For plotting we need the data to be loaded in the algorithm, so let's fit the data first, right? So we'll say k-means dot fit, and get the data there. So this is actually giving us the output, but at the same time, it's giving us a warning, right? So it's saying there is a chance of having a memory leak on Windows with MKL. So it's giving us an option for avoiding the leaking. It's giving us an option to set the environment variable as so and so. For now, I'm just like ignoring this, right? And then let's print the labels as usual, to see what labels we have.
So what is the cluster parameter helping here? That's a question from
Okay,
Swarna.
cluster parameter. Okay, so as mentioned, k means the name itself says how many categories of clusters of data you want to prepare with the data that you have, right? So here in this case I'm setting it as 3 because I want to categorize this data into 3 clusters. So we are just setting that k value here. I hope that answers the question.
Yeah. I think after they see the classification, they will see.
Yeah, correct. So let's see. See, this is the data that we have in the labels. So we have a collection of ones, zeros, and twos, like basically three sets of data, right? So that we did fit in the data into this k-means algorithm, and we said that want three clusters. So it's actually now categorized into three groups, right? All the data into three groups, and it's naming it as 0, 1, and 2 for us to easily understand, right? So now the next thing is, now that we have all the data with us, let's plot it now, right? And we have used this matplot library. So, and when we say as, I know you know what import is now. Whenever we use an import, this is like kind of a function, and you can use it with parenthesis. But when you say as, it's like aliasing. So like, say if I'm Aditya, I like friends call me Adi, right? So Adi is my alias, right? In a similar way, when you say as PLT, which means like we are aliasing this library as PLT, instead of using this name, complex name, we can just use it as PLT, right? So for that reason, we'll just say PLT dot scatter. I'll just use this scattering and show you what how it looks. I have the code to plot this. So let me use this. Let me just use this. So what we are doing is we are going to scatter this. Here we are just showing what is x-axis, what is y-axis, and then the data. Data is like k-means labels, and cmap is nothing but the color coding that we want. This is a predefined color coding that this library uses. So this is a color coding. Cmap is used for color coding, and then we are just, for beautification purpose, what we are saying is we are adding a title for that. We are saying k-means clustering for iris data, and on the x axis we are giving the name as feature one. On the y label, just think it as a 2D graph, right? So in the y label we are giving it as feature 2, right? And then let's show this data. See this now. We are having three groups of data, one for feature one and one for feature two, right? And all that, uh, I mean, like, because of the color coding that we are using, we are having this dots in yellow, blue, and maybe green color, right? So this is just a sample data that we are using from this sklearn data set, the iris data set, and we are categorizing. Just I'm recapping it one more time. So we got the data from iris data set, and we loaded it in iris, and we are saying we are getting the data in the data variable, and we are initializing the k-means algorithm. For the k-means algorithm, one mandatory variable that we need is we need to tell them algorithm how many clusters we want to create. So in this case, I'm creating three clusters, and random state is for getting a same result n number of times whenever we use the same random state. So I'm using 42 as a random state, right? And then we are fitting the data into this k-means, whatever data we imported from sklearn. And after that, once that data is fitted, for testing purpose, we are seeing what the labels are. We are checking whether the data is classified into three groups. Now that we know, we see the data is classified into three groups, then we are using the plotting library, matplot library, for plotting it in a two-dimensional graph. That's what we did.
So Satvik is asking, what is the use of the scatter, right? Is it just to show the clustering information, or what else?
Yeah, it's just to show this clustering information. Basically, scatter is a predefined method in the plotting library, which will actually display the visuals in whatever way you're seeing.
So he's also asking, we use only data 0 and 1 only, but how is it showing data 2 also in the scatter?
No, it's not like 0 and 1. It's more to do with the dimensions. So it's I'm not saying this 0 and 1 doesn't mean the 0 and 1 in the labels. It's
It's the x
actually
and the y axis, right?
it's
Yeah.
x and the y axis basically.
Yeah. Also, the 0, 1, 2 is basically from that labels, right, Satvik? If you see, right, if you just want me to explain in layman terms, imagine that there is a huge data set. We want to split them and categorize into three different categories, like we saw in the Flipkart example, right? You want to have high spenders, low spenders. Now we are going to do it into three different categories. Now splitting those into three different categories, how many of these data elements are there, right? And that's why you see that scattering. right? And based on the feature 1 and feature 2, it's moving into different x-axis and y-axis depending on the number, right? I mean, that is why you see some of them are 4.5, some of them are 3.5. So that is how we are grouping them, right? So that way you can, here we are just calling it feature 1 and feature 2, but then let's say you have a you have a specific use case, you can have those use case names, right? And then you know how much data is coming into the feature 1, how much data falls into the feature 2, and then how these are clustered, right, for the probability prediction.
So I'm
Hope that
just playing
answers.
with.
Yeah.
So I'm just playing with this. There is another variable s on the scatter method. So
Okay.
this will help us to reduce the size of the dot. I feel the dot size is too much. So
Mm.
so
Yeah,
I
yeah,
we
yeah,
can actually play with this s variable. So see now,
yeah.
if I use the value as 10, the dots dot size is very small, and maybe let me for you to identify it very clearly. I'll now make 10 to 40. So now you see the dot size has grown so much, right? So yeah. So there are other lot of other variables in this scatter method. I just found
Yeah,
this
but the usage of
as
scatter is basically to understand how
plot.
dense and how are we grouping and clustering the data, right? I mean, that is the only reason we are using it,
So
because there are
to
so
make
much
it
of data you cannot just understand, right? I mean, just this is for our purpose. Yeah,
correct. To make it
yeah,
very
good.
simple, right? It's like think like scatter is a print statement. Okay. So maybe in Python, if you want to print something, you're using a print statement, right? In the similar way, scatter is like a print statement for the plotting library. And for that, four parameters that are mandatory are x-axis, what is x-axis, what is y-axis, and what is the data you want to plot, and then what is the color combination you want to plot the data with, right? And there are in a lot of other even CMAP is also a is not a mandatory field, and there are a lot of other optional parameters that we have where we can use to customize this map and make it more beautiful.
Swarna is asking, it printed the plot without the plt dot show dec call, deck call, but then we did that call, right, Swarna? I mean, we have a plt dot show.
Yeah, we did that.
Yeah.
We already have that.
Yeah, just that we are just running these commands together,
Yeah,
right?
together,
Unlike the
correct.
earlier. Yeah,
Yeah.
that's the difference.
Just to save time, I'm actually like had it all this in the single block
Yeah.
so that you can see the results and we can talk more about that.
Awesome.
Right. So yeah, this is how we uh, use the uh, two types of algorithms. One is k-mean, and the other one that we just saw is a random forest classifier, right? So there are multiple other algorithms you can go and try from this library sklearn, right? And maybe Ajay, do you want me to share the assignment and walk through that
Yeah,
assignment
yeah,
with
yeah.
you?
Go ahead. Since you have the screen, I think we can do that. If you go to
Yeah,
the GitHub
yeah, yeah.
link, I think we can do that. Yeah.
Uh, yeah. Ajay, can you share the GitHub link in the comments so that
It's there in
everyone
the. Okay. So yeah, it's there in the private chat as well, and it's there in the comments. Askar
oh,
has
in this
added it.
comments? Okay, okay, okay.
Take a look at our
Oh yeah,
private comments. Yeah, just open that,
right,
and
right,
then we
right,
can.
right, right. Just opening that.
So Karthik is asking, is there a way we can give a data and understand which cluster our data belongs to?
Yes, yes, we
Specific.
can do. Yeah. So right now I'm taking the data from the skikit library, and just for randomizing purpose and to make things easy, we are using the data. But you can use your own Excel sheet as well. Like if you have an Excel sheet,
No, no. I think he's
uh,
asking a specific data. Can he understand which cluster is it part of?
oh, okay, okay. Yeah, yeah, you can do that. So for that, what we need to do is again split this. Right now, what I've done is I just got all the data and plotted it on a XY two-dimensional graph. So for that case, what you need to do is you need to split the data again into a test set and a training set, and you train the data and plot in a 2D graph with three groups or four groups, whatever it is, and then you use the training data set, add a different what do you say color combination or whatever, right? And then see where that training set will be plotted in that xy dimension. You can do that. If you want me to
Basically, you
add
have
an
to
example,
segregate that separately, Karthik. So you have to segregate
correct,
your data separately, and how you can do that is using the train test split.
right. And Karthik, if you want example, I'll try to add some example in that way in our GitHub repository. You can get it from there.
Swarna has a
So
question. I have one question, which will this be used by LLM internally when we ask categorization question, or is it different?
okay, internals to LLM, we never know what LLM, like the model,
Library they are
existing
using.
models are
Yeah.
using, what, like proper. We don't know what model it uses internally, but obviously it's a unsupervised learning. That's for sure. We don't know whether it's a k-means or maybe some other unsupervised learning algorithm, but it used some sort of unsupervised learning algorithm. That's for sure.
Yeah, Swarna, it is like imagine LLM is a very high level stuff, right? I mean, whatever we are now learning is at the machine learning and the low level stuff, right? And that's where we are looking at these algorithms and things like that. So maybe these LLMs internally use some sort of these algorithms, or maybe combination of these, and then try to see the accuracy, and then they come up with a better result. Suman has a question: can this library load data from PowerPoint presentation?
PowerPoint presentation, I'm not sure it can load the data from Excel sheet for sure. I've tried it. It works. But PowerPoint, what kind of data you have in PowerPoint? If it's a
Maybe like
tabular
images also might be there, right? That's what I assume. What
images,
Suman
yeah,
means.
maybe what you need to do is maybe if you have some library which supports PowerPoint, you need to. I've worked on a library for PowerPoint in .NET actually. So what it does is, so it will import that library, get the file, and it has a method to get all the pictures in that PowerPoint and have it in an array, stored in an array, and then use that images for training on some model.
Yeah, also we
I
can do
think you
image
can.
recognition, right? Adi, I mean, like we can convert the PowerPoint presentation, like have these images converted into textual
Right,
format using the image recognition libraries, and then
right.
use that data to into these algorithms. Yeah, you
Yes,
might
yes, yes.
need
We
to
can do
do
that.
multiple level of transformations, Suman. Yeah.
Correct. Okay, let's pause on the questions for a moment and go through the assignment, right? We have the assignment in this URL. I think that URL is already posted in your chat here, right? So the day two assignment is you need to build a machine learning model for classifying the handwritten digits. You might have seen the CAPTCHA. Whenever you are registering a form, you get a text with a combination of characters and numbers, right? And when you enter some number, it will say whether the entered number is matching the image or not, right? How is that happening? Internally it uses some kind of this like image recognition or the text recognition algorithms internally, right? So you are going to build something similar. You are not going to like write any kind of algorithms as such. You will use the existing algorithms, use the existing training data set, but make sure how you use it. I mean, like there are multiple algorithm options for you. So which algorithm is a best suit for this uh, problem statement? That's something you need to figure out. And also create a code in the same way that we just done, right? And all of that details are mentioned here clearly, starting from how to install Python. Either you can, as mentioned earlier, you can install Python from python.org downloads, or you can also install the Anaconda that we just saw, right? And then all the libraries that you need to install using pip install, you can install that. And if you're using Anaconda, this is the command for that, right? And then if you have done assignment one, you might already know how to use GitHub, because assignment one also have like you have to actually submit your assignment using GitHub only for assignment one also. So this is just for those who are coming new. And then this is where the assignment detail starts. So you can get the data set from the skikit-learn library. We have given the link for that also. So here you can find the data set of all that, and then load the data, splitting the data, training the model, whatever we've done just now for the supervised learning algorithm, right? And then finally, once your code is done, push it to your repository and submit it in the form. We have also given you a template here as a starting point. So we don't want you to use the same template and submit the assignments. Instead, we want you to use different algorithms other than random forest classifier. You can use forest classifier for sure, but try exploring different algorithms and see what is the accuracy for each of those algorithms, right? And once that is done, so you can just submit that in your GitHub repository, and use this link. Ajay, did we show this link already before? No, right?
No, I didn't show it. Yeah, you can maybe show it. And
Okay.
also, I want to call
Yeah,
out like a few folks who have already submitted day one assignments, like Shivani Satvik has submitted, Prakship Kumar Rai he has also submitted, Vedashri is also done. Right, so I want to appreciate you guys taking time in submitting these. I would also encourage people who are seeing these sessions. I mean, take a look at the first one, and again, it's a very easy one. It will help you understand how AIs are functioning internally, right? Whatever you do
correct.
in your day-to-day life. Yeah,
Correct,
yeah, go
correct.
ahead.
Yeah, and huge shout out for all those who submitted. You can maybe just clap them, call out in the comments. Thank you guys. Keep participating more and more. And yeah, coming to the format of the form, so it's very simple. So this is the same form that you're going to use for all the 8 assignments. So today we are launching the second assignment. So what you need to do is add the name, email, phone number, and then select the day 1 to 8. Maybe if you're submitting today's assignment, select day two, and then paste your GitHub repository, and then add your current professional status and just submit it from here. So we'll go through all the assignments that you've submitted, and we'll choose the winners based on the criteria that is mentioned in the same assignment. So if you go down at the end, we also mentioned the winning criteria, right? Completeness, code quality, observations, and the GitHub usage. So go through that evaluation criteria also. And if you have any questions, feel free to add your questions in your uh, in the uh, in the place where we have the collab channel, right? So anything to add, Ajay?
I think we are good. I think we are good. Again, any questions offline, folks, feel free to like post it in the discussions. I already saw a lot of folks posting there. Good to see that we are starting these discussions. We want to keep that discussion going. The next session will be again next week. But then, meanwhile, if you guys go through ahead in the schedule, right? You know the schedule, what we are going to talk about next week, right? Data preparation and some of the deep learning basics. I mean, take a look at these. Maybe do some prep work, right? Take a look at these repos, take a look at these code, have some hands on around what these algorithms are, maybe research some things deeper, right? We are just covering whatever we can cover, but then please do take a look at those during the next few days, right? That will help you as well. And again, once you come back, you will have a better understanding of what we are talking about. Yeah. Yeah, Satvik, we'll upload the code which Aditya showed as well. So Aditya, what we can do, we can create a new markdown file and then upload your code
Sure,
there
sure,
so that
sure,
people
sure,
can
sure.
also just
I'll do
reference it. Yeah.
I'll do that. I'll do
So
that.
that should be
And
available, Satvik, in few minutes. Yeah.
yes, yes. And team, whoever is participating regularly, do encourage your friends from your college or your office, wherever it's possible on your social media handles. Just share this. We already have our posts on LinkedIn. If you want, you can share the link of that LinkedIn post, and just encourage them to participate, and ask them to go through the first 2 sessions. They will be recorded, and these are recorded, and they will be uploaded in the same Azure Developer Community YouTube channel. So ask them to go through the first 2 sessions so that they'll feel more comfortable when they are attending the third or fourth sessions, right? So yep, I think
Yeah,
that's
the
all
links
from
are
me.
also in the GitHub repo, right? So I have already updated today's link as well. So people can, who has the access to the GitHub repos for each of the days, there is a recording link. So they can just click on the recording link and then watch these recordings as well, right? So we have made that also available.
Yes, perfect. Cool then. Anything else, Ajay?
I think I'm good. Thank you, folks. Thanks for your time. Spending almost an hour and a half or more with us means a lot to us. And also, we are also learning a lot along with you. Ask some questions. Same way, be prepared for the next sessions. We'll be like looking forward to a lot of questions and more interactive talks, right, going forward. Um, yeah.
Yes, yes. So this
Have
is
a
just a
good
start.
weekend. Yeah.
Yeah, this is just a start, and we have 6 more sessions coming up, and all of them are going to be hands-on. It's not just theory all the day, right? So a lot of hands-on, and you'll learn a lot of new things in this next 6 sessions. So all the best for that, and thank you so much for your time.
Yeah.
Azhar,
Thank you, folks.
do you want to
Yeah.
close it? You want to add anything?
No, I'm good. Thank you so much for an insightful session, Ajay and Aditya. And thank you everyone for joining us today on a weekend. I know everyone wants to party on a weekend, rest, but you
I
guys have
think they can
joined
still
us
party.
today.
It's 8:30. So party can still start in on a Saturday
Yeah,
evening.
Yes,
But yeah,
yeah, yeah, yeah.
yeah.
yes. So all the best. Have a great weekend. Thank you so much. See you in the next session.
Thank you so
Thank you
much.
so
Bye
much.
bye.
Thank you, man. Bye bye.
Bye.